The most widely used programming language in the world was designed in just 10 days. But that is not a limitation. That is the origin of a philosophy. This is the story of JavaScript, why it works the way it does, and why understanding its philosophy makes you a better developer. The year is 1995. Netscape Navigator is the most popular web browser in the world. But web pages are just static documents, no buttons that respond to clicks, no forms that validate input, no animations. Netscape hires a programmer named Brendan Eich with one mission: put a programming language inside the browser. There is a catch. The marketing team wants it to look like Java, the hot language of the moment. But it needs to be simple enough that web designers, not just engineers, can use it. Eich has 10 days to build it. In those 10 days, Eich made 3 decisions that would define JavaScript forever. First, variables have no fixed type. You can assign a string, then reassign it to a number. No compiler will stop you. Second, functions are values. You can store a function in a variable, pass it around, return it from another function. This idea came from a language called Scheme, a dialect of Lisp. Third, objects are open. You can add or remove properties from any object at any time. These 3 choices created the DNA of JavaScript. Those constraints shaped everything. 10 days meant there was no time to build a complex type system or a rigid class hierarchy. Browser scripting needed a language that could glue HTML, images, and user events together without fighting a compiler. The result was a language with a clear philosophy. Give the developer power first. Safety comes second. JavaScript trusts you to do the right thing. It will not stop you from making mistakes. Instead, it gives you the tools to build anything. Here is the hidden truth about JavaScript. It wears Java's clothing, curly braces, C-style syntax, the name itself. But underneath, it thinks like Scheme, closures, first-class functions, dynamic scope. These are ideas from functional programming smuggled into a language designed for the masses. That tension between looking simple and being surprisingly deep is the core of JavaScript's identity. JavaScript's philosophy rests on 3 pillars. First, dynamic typing. Variables do not have types. Values do. The language figures out types at runtime, not at compile time. Second, prototype delegation. Instead of classes and inheritance, JavaScript objects can delegate behavior to other objects through a prototype chain. Third, first-class functions. Functions are not special. They are values, just like numbers and strings. You can store them, pass them, and return them. These 3 ideas make JavaScript fundamentally different from languages like Java or C++. Dynamic typing means the variable itself has no type. The value it holds has a type, and that can change at any time. This is not sloppiness. This is a deliberate design choice. It means one function can handle numbers, strings, objects, or anything else without needing overloads or generics. The trade-off is that you might pass the wrong type and only discover the error at runtime. JavaScript chose flexibility here. It bets that developer speed matters more than compiler safety for most web tasks. In Java or C#, you define a class, then create instances from it. JavaScript does something different. Objects can inherit directly from other objects through a prototype chain. When you call dog.speak, JavaScript looks at dog first. Dog does not have a speak method, so JavaScript follows the prototype link to animal, finds speak there, and calls it. This is called delegation. There are no blueprints. There are just objects pointing to other objects. It is simpler, more flexible, and honestly a bit weird at first. But once you understand it, you see the elegance. First-class functions are the superpower that made the web interactive. When you add an event listener, you pass a function as an argument. When you create a factory, you return a function from another function. This is the pattern that powers every click handler, every callback, every promise chain, and every React component. Brendan Eich borrowed this idea directly from Scheme, and it became the most important feature in the language. The web needed a language that could glue everything together. HTML gives structure, CSS gives style, JavaScript provides the logic and interactivity that connects them. Because JavaScript is so flexible, it can handle button clicks, form validation, animations, network requests, and anything else the web throws at it. One language, infinite use cases. That is the power of flexibility as a design philosophy. For years, JavaScript was a mess. Every browser implemented it differently. Internet Explorer did one thing, Firefox did another. There were no modules, no standard library, no package manager. Code was scattered across script tags and global variables. Then, in 2008, Douglas Crockford published a small but powerful book called JavaScript, The Good Parts. His message was simple. JavaScript has brilliant ideas buried under bad ones. If you learn to use only the good parts, you can write beautiful code. That book changed how the world saw JavaScript. Let us talk about the weird parts. When you add a string and a number, JavaScript coerces the number into a string. When you subtract, it coerces the string into a number. Double equals performs type coercion, triple equals does not. And type of null returns object, which is a bug from the very first implementation that was never fixed because too much code depends on it. These are not random quirks. They are the result of a philosophy. JavaScript would rather try to make your code work than throw an error and stop. It chose forgiveness over strictness. You may not always love the results, but the intention was always to keep things running. In 2006, jQuery arrived and changed everything. It gave developers one clean API that worked across all browsers. But here's the deeper lesson. jQuery was only possible because JavaScript is so flexible. The language's philosophy of open objects, first-class functions, and dynamic everything meant the community could solve browser problems without waiting for the language itself to change. JavaScript's flexibility turned its developers into its architects. In 2009, Ryan Dahl created Node.js and took JavaScript out of the browser entirely. The same language now ran on servers. The event loop, originally designed for handling mouse clicks, became an architecture for handling thousands of network connections. And NPM, the Node package manager, became the largest software registry in the world. JavaScript's philosophy of flexibility and composability scaled far beyond what anyone expected. The event loop is one of JavaScript's most misunderstood features. JavaScript is single-threaded. It runs one thing at a time, but it never blocks. When you set a timeout or make a network request, JavaScript puts the callback in a queue and keeps going. Promises go into a special microtask queue that runs before regular callbacks. The output here is 1, 4, 3, 2. Not random, perfectly deterministic. This design means JavaScript can handle thousands of events without threads, without locks, without race conditions. Single-threaded is not a weakness, it is a philosophy. In 2015, JavaScript received its biggest update ever. ECMAScript 6 or ES6 introduced let and const for proper block scoping, arrow functions for cleaner syntax, template literals for string interpolation, destructuring for unpacking values, classes as syntactic sugar over prototypes, and modules, finally replacing the chaos of global script tags. But notice something important. None of these features changed the core philosophy. They refined it. JavaScript was still dynamic, still flexible, still trusting the developer. It just gave you better tools. Modern JavaScript reads like a different language compared to the 1990s, but the philosophy is identical. Destructuring is flexibility. You take only what you need from any object or array. Arrow functions and array methods let you write functional pipelines with minimal syntax. And async await makes asynchronous code look synchronous, but it is still built on promises and the event loop underneath. The surface changed, the soul did not. TypeScript is perhaps the ultimate expression of JavaScript's philosophy. It adds a type system, but it is entirely opt-in. You choose how strict you want to be. You can type everything or type nothing. And at runtime, all the types disappear. It compiles down to plain JavaScript. TypeScript does not replace JavaScript's philosophy of freedom. It extends it. Safety becomes something you add intentionally, exactly as much as you need, exactly where you need it. Here is TypeScript in action. You define an interface that describes the shape of a user. The function greet expects a user and returns a string. If you try to pass an object that does not match, the compiler catches it before your code ever runs. But when this compiles, the interface disappears. The runtime code is plain JavaScript. You got the safety for free without sacrificing any of JavaScript's flexibility. So what is the philosophy of JavaScript? It is this: freedom over restriction. The language gives you power and trusts you to use it wisely. Runtime over compile time. JavaScript discovers types, shapes, and behaviors as your code runs, not before. Composition over inheritance. Small functions and objects composed together beat deep class hierarchies. Community over committee. When the language could not solve a problem, its community built the solution. And finally, discipline is your responsibility. JavaScript will not protect you from yourself. TypeScript, linting, testing, architecture. These are tools you choose to adopt. JavaScript gives freedom. Engineering turns that freedom into reliability. That is the philosophy of JavaScript, a language born in 10 days that now powers the entire web. If you want to truly master JavaScript, understand its philosophy first. Subscribe for more deep breakdowns, and I will see you in the next one.